way to test the range of your peripheral vision. Keep your eyes on me and put your hands out right in front of you like this. Now slowly start to bring them back, like I'm doing. At some point, you'll notice you can no longer see your hands out of the corner of your eyes. Now, pull them back slightly toward you until you can see your hands again. And that's the range of your peripheral vision. And while your entire eye is designed to track motion, your peripheral vision is much more sensitive to motion than the rest of your eye, though it's not exactly accurate at letting you know how things are moving. Don't believe me? Why don't you test your peripheral vision in this next game, which is sure to throw you and your brain for a loop. Look at the yellow star on the right side of your screen and keep your eyes there. Now can you tell me which way the dots around the yellow star are moving? Looks like they're moving to the left or counterclockwise, correct? Easy enough. Now, keeping your eyes focused on that yellow star, using just your peripheral vision, can you tell which direction the dots circling the red star are turning? Does it look like they're moving the other way, clockwise, and to the right? Okay, now I want you to look directly at the red star. Did the dots around it suddenly change direction? And have the dots circling the yellow star switched up too? I promise, we're not altering the image at all. To prove it, take a look back and forth at the two stars in your own time. The dots keep changing direction, don't they? Confused? Don't worry, you're not seeing things. Well, you are, sort of. It turns out the dots circling both stars are rotating to the left, but they also have fast-moving gradients within them. That's the shading you see going in the opposite direction. And if we remove that shading, your eyes clearly see both sets of dots rotating to the left. But when we add it back in, and you see the dots out of the corner of your eye, the motion of the shading overrides the actual rotation of the dots. That's because your peripheral vision is not as strong as your central vision and can only detect one type of motion at a time. So it selects the faster moving gradients as the primary indicator of motion, causing the different parts of your eyes to send different signals to your brain, making your head spin